Right, this is a short video showing kind of a hobbled together Google Earth version of Riverscape's decision support tool for the Price River in southeastern Utah. And so basically what I have here in the table of contents is just this nested Riverscapes setup here where we have the RCAT data at the bottom here. We've got the BRAD outputs, Beaver Restoration Assessment Tool. And then in this case, we also have a high resolution vegetation, riparian vegetation map that was collected using 1 meter imagery. And so we've been able to pull out tamarisk, Russian olive, and cottonwood extents and density maps. And so I guess a lot of the stuff might be a little bit underwhelming, but I think the idea is that if we could have the RAVE tool or somehow just exporting out KMZs that are embedded like this on the fly from the projects, I think that'd be very useful. And so I think just to highlight what we're able to do here. So, for example, this is mostly BLM land, and the BLM is interested in doing restoration and conservation work on the Price River. And so right now we're in the process, we're literally going to go out in the next week to pick out potential conservation and restoration areas. This kind of gray area that's here, that's the valley bottom of the study area, it's highlighted. This is the wilderness study area boundary. So that's kind of off limits basically for the restoration work. So we know that we're just going to kind of cut this off and say, hey, this is all conservation area. But if we go in here at the start of this canyon, this brown colored area is BLM land. And so this could be an area that could use some restoration. So if we look at our RVD, and that's the line work here, I'm just going to turn off the land ownership at this point. We can see these values of large departure from historic. And so these could be areas, and we could look at, well, do we want to bring beaver into these areas and potentially use them as a restoration agent? And so we see some of the capacities here of occasional, and so we could potentially see some dams. So what about potential conflicts with structures? We can bring in the conflict layer. We can see a highway here. So maybe you won't want to put beaver too close. You also have some land ownership issues, so you might want to not get too close to the private land. So these are kind of some issues that we can look at with this data. And when it's embedded like this in a viewer like Google Earth, it just provides that context and ability to use these data sets in concert. So we might also want to look at cottonwood. So as we come in here and we look at different type of restoration actions, what we might want to do is promote cottonwood growth. And what's happened is tamarisk, which is in this darker green, tamarisk has invaded these areas substantially. And so tamarisk removal would be an option where you come in here and you actually pull out the tamarisk, and typically we want to have a cottonwood seed source in those areas. So this would once again be a good candidate area because of the existing cottonwoods. Let's look at some other stuff. We've got aquatic habitat layer here that's coming up with riffles. I'll turn off the BRAT so we can just look at this independently. So we're trying to promote habitat. Maybe this is a little limited in habitat, so by removing some of the tamarisk and maybe putting in some structures, we could increase the complexity of the in-stream habitat here, because you could argue that it's potentially limiting or limited. So if we look at kind of a broader scheme of things, and this is about 150 kilometers of stream, the idea is we can use this as a prioritization tool, kind of that broad scale. And some of the limiting things as far as land ownership, so the red, we could basically say, well, this upper portion is off limits. We also worry about access, and there's actually very limited access in this area. But right here, we've got a road that comes in, a bridge, so this could potentially be a nice work as a potential restoration area. We're looking at the riparian veg departure here, those scores, and we see some high departure from historic in these areas. So as far as vegetation, that could be an interesting place to work. If we bring in the brat, there is some capacity, kind of these occasional capacities, and maybe some frequent capacities. So if we were to think of one of the restoration agents as being beaver reintroductions, that could be important. We can look at tamarisk, and just to give you an idea, these are just brought in as vector layers, so this is just hobbled together. So these aren't in the future it'd be great to use these as map tiles, but just as a demonstration purpose, the idea of how we can use these data sets together. So there's a lot of tamarisk, high densities of tamarisk. We can look at, so this is actually underlaid here is a density map of tamarisk. So the more red the color, the higher the densities are. So in this case, tamarisk are bad in that they're an invasive species that allows for this vertical accretion to the floodplain. So you have this removal of the stream is no longer able to access the floodplain, and so typically these restoration actions involve tamarisk removal. Another species of concern is Russian olive that shows up in this green color, and this is a new expanding invasive species that's just starting to really hit this area. A really interesting pattern is if we look throughout the watershed, they've really only gotten down to about halfway through the Price, and beyond about here you can already see that there's very few of them, and as you get to the canyon, so it's a species that's moving down stream, but in limited numbers in some of these areas at this point, compared to the upper reaches where it is really taken over. And so other restoration actions would be removal of the tamarisk. So I guess as thinking about this as a decision support tool and thinking about it in the context of riverscapes projects, for me what's neat would be for these to be automatically spit out in kind of these nested ways that we create kind of this decision support tool, and then I see this as something that you can work with land managers with. So this morning I met with BLM representative, a manager for this area, and then also another university researcher, and we basically use this information that I'm showing you to come up with these potential restoration sites that we'll go out and visit next week, and then to really interrogate how good this remote sense data is, and whether we've actually picked sites that are going to work for priority restoration conservation areas. So that's just a kind of a short run through of what I see in the Google Earth interface, where I think a lot of people are going to be consuming this data in Google Earth and how it could look. And this is a hobbled together version, but I think even this, it was surprising how well received it was and how useful it is as a decision support tool in restoration planning. I'll end it there.